So this conversation, this debate is going to be based off of the level of understanding. How well do you understand basic scientific concepts? How afraid are you of white people? So if you think the earth is flat, then you're clearly afraid of white people. Must be secretly because it's the white people that you talk about that you really hate that actually made this whole thing up in the 1800s. The thing don't get popular, like I said, until quote unquote, there goes the slide, there they go. Hold on. There go. Get around it.
This is the source of a lot of confusion. This is the source of a lot of flat earth foolery and confusion here.
Boy.
So when we talk about buoyancy, of course, this is buoyancy in accordance to the Archimedes Principle. Right? We don't want to scare off anybody with equations, so we won't get into the heavy math of it. But essentially, let's say this in layman's terms, what we call the buoyant force, which is an upward force, which is FB, you see on the left. Essentially, that's a force. There's a magnitude of that force, and it's directional. That force is upwards, away from the earth. And what this equation is telling you is that the magnitude of that buoyant force is equal to, right, the density of the fluid, right? The fluid could be either water, the fluid could be the atmosphere. Again, like I mentioned earlier, both a liquid and a gas can act as a fluid. So the magnitude of the buoyant force is equal to P, the fluid's density, times G, that's the gravitational acceleration due to gravity. Or remember that little G? Remember that little G? Ooh, right? Times V, right? Which is the fluid, the volume of the fluid that was displaced by the object that you submerged in the water or the fluid, right? I'll give you an example of this. A very simple example. You take a beach ball.
329, right? Physics book.
Yep, exactly. So take a look at the Archimedes Principle. It says any fluid applies a buoyant force to an object that is partially or completely immersed in it. The magnitude of the buoyant force equals the weight of the fluid that the object displaces. I'll give you an example. Take a beach ball, right? Blow it up with air. You submerge it in a swimming pool. Everybody knows that you feel a buoyant force, that there's a force that's pushing that beach ball back up to the surface of the water, right?
Yep.
Right? That's that upward force, the buoyant force, right? There's a magnitude to that force. The magnitude of that force is equal to the total weight of the water that was displaced by the beach ball. You can test this if you take the beach ball out of the water, fill the beach ball up with water, right? And then put it on a scale, right? Because that is the total amount of water that was displaced by that beach ball.
Yep.
So the weight of that beach ball that's filled with water, that's the actual magnitude of the buoyant force.
Yep.
Right? What this is telling you is that the water or the fluid is trying to reach a state of equilibrium. Right? That beach ball pushed water out away in the pool, right? That fluid is actually trying to get itself back to that original state of equilibrium. And that buoyant force is the force that you feel when that action happens.
Yes. Pushing the ball up.
Yeah. And it has a lot of applications, right? Like for instance, you could actually test the purity of metals using the buoyant force, right? We use it in chemistry a lot, you know, and in engineering as well, right? And this particular equation tells you why you could take a super tanker that weighs tons and it'll float, but if you take a penny and drop it in the ocean, it'll sink to the bottom.
Yep. Go figure that, folks.
Yeah, it won't get past that first slide.
Don't use buoyancy. Don't use buoyancy.
In the middle
Don't
there,
use buoyancy.
the acceleration.
We're now taking buoyancy off the table. What else we taking off the table?
The same thing that happens with the beach ball example. The same thing, the same principle applies to a balloon filled with helium.
Yes.
right? The same principle applies, but this is in reverse almost. Think about it. The weight, the buoyant force, right, that's applied on that on the balloon filled with helium is less than the magnitude that's on the right side of the equation.
Mm-hmm.
So that's why it's actually resisting the force of gravity.
Yes. That's the
Right?
same principle with a hot air balloon.
Yes,
You take it there,
exactly.
you hot
Same
it up,
principle.
you increase the volume, and now you get an upward force because that propulsion overcomes the weak force of gravity.
The weaker force. Right. Yes. In this instance. That's it. That's the buoyant force.
Yes,
And
by creating a
Archimedes, and you can congratulate Archimedes for figuring that piece out.
Archimedes has defeated the flat earthers once again.
So are you saying, Brendan, that this is nothing esoteric? This is something that you would have to learn. There's nothing
What?
esoteric.
You can test this. You can test this in your kitchen.
Yep.
You can
Right.
test this in your kitchen. Get a glass of water. Get a small ball from your from your kid, right?
So you would have to go to no
fill the
special
glass,
school.
fill the glass of water up to the rim, right? Submerge that ball in the water. You're gonna get some water that's gonna spill out of that glass. Take all of the water that spilled out of the glass, put it in another container and weigh it. That's
So
the
you wouldn't
magnitude
need
of
to
the
go to
buoyant
no
force.
special school to learn this.
No, well, yeah, it's called probably the 8th grade.
Yeah.
It's a special learning institute called middle school. Yeah.
Oh shit.
Hey, let me do. Brendan always do that shit, man. He look, complicate the shit, get all y'all. He hit y'all with the college level. Look, we're gonna do this. Look, here you go. Hey, it's right here. Here you go.
There it is.
Can't get past Wikipedia, sir. There you
There it
go.
is.
See, there's experiment right there. Look, the forces at work. Buoyancy.
There you go.
The object floats at rest because the upward force of buoyancy is equal to the downward force of gravity. There you go. See, that's how I bring it. I know
There
how
it
he
is.
bring it. That's what I'm doing. I'm not doing all that. Look, it's over with. Game over. Don't use it.
The basic principle behind
Don't use it.
What do you mean? That's what I said, huh?
Yeah, that's what Brendan said. The principle behind the hot air balloon physics is the use.
I have a tendency to take the long way around the barn, as you know.
So by